getting into our last part of our notes. So this would be the Pedigree Part 2, or the fourth section of this unit. We're going to finish up looking at pedigrees. Last time we looked at, this is a clear example of a pedigree on the screen right now. Remember, pedigrees are not family trees, but they do have a lot of things to do with a family tree in that we can kind of look at generations and see patterns. What really stands it apart is the shaded portions, the red portions here. This would show, in this case, Huntington's disease. The people that are shaded, of course, have whatever phenotype we're looking for, what is physically seen or coming out. So these shaded portions here, the red ones, would have Huntington's disease. And we can kind of see how it goes through generations. We can also see, what happens when parents that maybe one of them has a disease or doesn't have a disease, or as we'll see in a little bit, one's a carrier. What do the offspring actually look like? Okay, so we're going to dive a little deeper into this. You'll notice in the next portion of the notes, it asks you, without shading any circles or squares, because we're not really considering any genetic traits, I want you to try to draw a pedigree of your biological family. I'd like 3 generations just so you can get some practice with vertical and horizontal lines. But I'm not checking this or anything like that. And if you'd rather just make up a pedigree chart using an imaginary family, that's fine too. Our families don't look alike, do they? Some of us have, we live with our biological mother and dad. Some of us, have a step parent, and they may love us like a father or a mother, like a real one. We may call them those names. We don't get any biological material from them. So therefore, I know as cold as it sounds, but for science purposes, they don't contribute anything biologically to us. So you would not include step parents and things like that, or step siblings, in our chart unless we have one shared parent. Okay. So anyway, I'm just going to do mine real quick. I'm just going to start just to kind of give you some ideas, and that way I'll label it as I go. This is me. Okay. This is me. I'm a square. And because that represents a male, I am married to my wife, okay? But remember, that's not just a marriage line. That's a coupling line or a relationship line, or however you want to call it. In other words, we have babies together. That's what it really matters. All right, and we can go on down from there, because remember, vertical lines, up and down lines, signify offspring. And y'all probably heard it from me time and time again. I have 2 girls, the oldest of which is 6, and the youngest of which is 3. They're about to have a birthday next month, actually. So anyway, this would represent me, my wife, and my 2 daughters. Now let's take it up a level. Now remember, I am the offspring of my parents, okay? So I have a biological dad and a biological mom, okay? Now, I'm not the only child. In fact, I am one of 3. So vertical lines coming down mean offspring. And remember, we do this kind of cool-looking little chart thing to show siblings, okay? To have all these different siblings. Now, if it was just one, it would come straight down like right here. But there's 3 of us. I have an older sister, and I have another older sister, okay? So I would be the baby. So we can gather all that from this chart. Now, in filling it in, looking at all the different parts, my oldest sister right here is married to a guy, okay? So notice he is not any connection to my parents right up here, okay? He's not biologically related. He's simply married into my, with my sister, into my family. They have 1 son, okay? So it would be shown something like that. Wow, that was kind of magical. This other sister, she was married to a guy, and they actually had a daughter, okay? Since then, they have gotten divorced, but you would still leave this line in here. Now, a lot of charts you'll look at may have something like this, kind of showing that relationship has been severed, but they still, have that biological daughter together. Some of us may be in that boat. She has since gotten remarried and had a son. Okay, so our chart would look something like this. Of course, this one would want to come down a little farther, just so they're all in the same row. All right, so this is kind of my family, my side of the family. This is me right here. Okay, and you can see lots about me just if you looked at this chart. So I want you to take a couple minutes and try to fill in your chart best you can. If you just want to write it out on a sheet of paper, like I said, I'm not grading it or looking at your notes or anything like that. Just wanted you to have the opportunity to play around with it, making sure you understand the coupling lines and also the offspring lines. And it gets kind of fun. actually, when you really start looking at, say like my sister here that's had 2 marriages, how that kind of ties together, because it's all important biologically. Both of these children here, we need to understand who their parents are, not only their mom, but also their biological fathers, okay? So looking at your notes, take some time, pause the video, whatever you want to do, and take some time to do that. All right, looking at the rest of our notes, this kind of links back up to our very first section, the notes that y'all actually had last week when we were virtual. Some genetic disorders are called X-linked. You might also hear them called sex-linked disorders, and they're carried only by females on that X chromosome. Okay, so they're carried by females. Males, of course, as you remember, have an XY genotype, meaning they got the X from mom and the Y from their dad. If their only X allele has this disorder, they don't have another normal or, without the disorder X to possibly mask it. Remember that X inactivation that we briefly looked at in our notes. But females, however, have an XX genotype. They can be heterozygous and have one recessive allele but not have symptoms of the disorder, meaning that they could be carriers of the disorder, meaning they may have the potential to pass it on, of course, in one of their X chromosomes that they'll pass on, but they may not show it because the other X chromosome takes precedent. It inactivates the other one. So, in sex-linked pedigrees, because we can look at disorders that are sex-linked, like color blindness, both chromosomes are providing the genotype with superscripts. That means that little number or letter moving up a little bit, showing if the X chromosome carries the disorder or not. So let's look at this chart, and we'll answer a few questions. Take some time now. Look at some differences here. Notice that there's no Roman numerals over here, and that's okay. It's just a different way to look at it. So we don't really need those because in this chart, they've actually numbered 1, 2, 3, 4. Notice how that they're just simply numbering the individuals. Now, sometimes these charts may be more beneficial than the Roman numeral, like individual 1, 1, or 1, 2, or 2, 3, or, whatever. So I like this one personally. And also you can kind of see the half shaded ones that we mentioned in the first part of our notes here. That means they're a carrier, that they don't display that trait, but they do carry the potential to pass it on. Okay, so looking at our questions on here, this is for color blindness, and it tells us all this right here. Okay, color blindness is a sex-linked gene that is recessive. It's recessive, so it'd be signified by a lowercase letter. And it gave us this example. And it is carried on the X chromosome. It is X-linked or sex-linked. Okay, so notice this would be, first off, we can see it's a male because it has X and Y. And then it's a recessive. That's horrible writing. I'm sorry. It has a lowercase m, meaning that they do have this disorder because it's recessive. You got to know if it's recessive or dominant disorder, just like in section 1 we learned about that. So let's just glance up here at the pedigree for a minute. So we see mom and dad in the parental generation. This would be dad. Not only do we know that because of the square, we also know it because he has an X and a Y. And we see that he is capitalized on the X-linked, trait for color blindness. So that means he does not have it. Of course, we know that already because it's not shaded in. Mom here, okay, we know it's a circle, and we also know that it's a mom because it has XX down there. And then the superscripts, those smaller letters up top, shows us that she has one dominant and one recessive, meaning that she does not have it because it's a recessive. Okay, she does not have this color blindness, but she carries the potential for it. She's a carrier, right? She's a carrier. Okay, that's what that means. We're just needing to understand how to read these pedigrees. So looking down, think for a minute, how many kids does this parental generation have? If you said 4, you're right on. Here's the offspring line, and we see that connected to that line, there's 1, 2, 3, and 4. Okay? The other people not connected in this generation are couples or marriages or whatever, spouses. All right. So looking at this chart, let's just glance at a couple things. Going down to our questions down here. Erase so far. It says, is number 7 colorblind? Number 1 down here. Is number 7 colorblind? We come to number 7 here. Are they? Yeah, they are, because they are shaded in. Remember, it's easy as that. How about 14? Is 14 colorblind? No. Remember, to be a carrier means you do not have that condition or that phenotype, but you have the potential. And she's signified by a partially shaded. We can also look at her genotype here and see that she is heterozygous. Okay. So number 2, why does 5 have 2 potential genotypes? This is a tricky one. Okay. Now look at 5 right here. This is a female that is not in a relationship, not married, not coupled, not have a spouse. So therefore, we don't know anything about her offspring because she doesn't have any. Like this female, we can tell a lot about her based on these offspring, and we're going to look at that a little bit probably later on. But this one, we don't know. We only know that she has the potential to get this genotype and this genotype from mom and dad. Think about what mom and dad would pass on. Let's just set up a real quick Punnett square from this parental generation. So we know one is X, capital M, and Y. That's dad. And then the mom is X, big M, and X, little m. Okay, hopefully you're sticking with me. So we know that they had the potential to pass on big M and big M. Okay, we're not going to worry about the X and Y over here because she's a female. Same condition here, bringing it over and over, up and over, down and over. Here we see big M and little m. Okay, so a homozygous dominant and a heterozygous. That's why she's got 2 listed right here, because we don't have enough information. Okay, we do know that she could potentially be a carrier based on that genotype, just like her mama's. She could be a carrier, or she may not have any potential to pass on color blindness. Okay, just not enough information. So that's the answer number 2. Why does 5 have 2 potential genotypes? Because we don't know enough about her. All right, looking at number 3, draw a Punnett square showing the potential offspring genotypes from parents 3 and 4. Let me erase so we can kind of get a clear picture going on here. Okay, so just like we kind of saw in that last one, same principle here. So we're looking at 3 and 4, these parents. Now, we already know their offspring right down here, but let's set up a Punnett square. Okay, so we're pulling in our old tools, making it a little bigger so we can see it pretty clearly. All right, so looking at dear old dad, number 3 up there, we're bringing X, big M, and then, excuse me, look at me screwing up. You're not the only ones. X, big M, and then Y, of course, over this box. All right, and number 4 now, mom, X, big M, and then X, little m. Okay, we're going to bring down, bring over, bring down, bring over, right? So this first box would be X, big M, X, big M. This next one would be X, big M, and Y, we're bringing back our basics we learned in last unit. Down here would be X, big M, X, little m. Oh, that's hard to see. I'm going to put a line under it so we remember that. And then this one will be X, little m. There's a line and a Y. So look at what the possible offspring could be. We have, we got like 25% on all of them, each and every one of these. So we have X, big M, X, big M. So this person would be a female, of course, that does not have color blindness because it is a recessive trait. Okay. Then we have another female that has big M and little m. Okay, so this would be a carrier, correct? But she would not have, I don't know why I'm doing X's, that'd be confusing. She does not have color blindness. And so then we have our males, okay, and this one, big M, would not have it. So none of these would have color blindness. And then we have the last section here, X, little m, and Y. Now, color blindness is an X-linked trait, right? And this is a little m. It's a recessive sex-linked trait or X-linked trait, meaning that what's the potential for their offspring, this one here and this one here, to have colorblind children? It would be 25%. Okay, 25% to have color blindness. Now, what's kind of cool is we can actually look up right here and see that that's how it turned out. We got 1, 2, 3, and 4 children, and only one of them had color blindness. So they kind of kept it related to those probabilities. Although we know, hopefully, that they could have 20 children and all of them have color blindness, but they all had a 25% chance of having color blindness when they were born. Okay, so this is just a different way to look at a pedigree. There's some positives and some negatives. You may like this pedigree way more than this other one we did from Huntington's disease, but I just wanted you to interact with it. Again, we'll have some assignments that will have hopefully fill it in a little more. I want you to make sure you can kind of see how we can pull this information from up here and turn it into Punnett squares as well, okay? We'll look at it together. If you have questions, as always, ask me. Hopefully you've enjoyed this unit, and hopefully we're going to do great on the exam.